So, good evening, and my name is Abi Nathaniel, and I'm presenting on two aspects of computer architecture today, and then two questions which I read are why does the data path cycle have a huge impact on the CPU, and then secondly, how does the CPU fetch, decode, and execute instructions. So, firstly, we will move to the first question, which is why the data path cycle has a huge impact on the CPU's performance. So, firstly, the CPU consists of two basic parts, which are the arithmetic logic unit and then the control unit. And then the control unit consists of buses, which is the control bus and then the data bus. And then so the arithmetic logic unit is responsible for helping the CPU retrieve data from the arithmetic logic unit through the data path and then the registers. So straight up, you're looking at the impact the data path cycle has on the CPU. So firstly, it is performance optimization. When we say performance optimization, we are saying that the data path, the performance optimization or performance optimization or performance metrics. So we are saying that through the data path, the CPU is able to achieve efficiency through the IPC, known as the instructions per clock. So this has to deal with time. So we are saying that with the central processing unit, the data we are saying that with the data path cycle, it helps the central processing unit through the instruction per clock, which means that through the instruction per clock, the CPU is able to achieve efficiency. It's able to work smoothly. It's able to work faster, in the sense that the system may not have any difficulty or overheating or overpower consumption. All this as a result to the performance metrics, or as a result to the instruction per clock playing a role in the CPU, whereby the CPU through the data path cycle is able to retrieve and then execute instruction which it is being fed to. Secondly, we are saying that another huge impact the data path cycle has on the central processing unit is the pipeline efficiency. So this is whereby the data path cycle helps in the determination of the CPU's efficiency, which leads to which may either lead to an increase in power consumption or an improved performance of the CPU. So let us take this scenario that so we first of all we know that in pipelining multiple executions can be done, right, which leads to parallelism. So whereby parallelism is achieved. So with this, if there is if there is an inclusion of parallelism, then it means that performance can be easily improved. But if there's an exclusion of parallelism, whereby multiple or many executions can't be carried out or many instructions can't be executed at the same time, it's only going to lead to power consumption and then a longer time of executing instructions. So we are so the data cycle helps the CPU to be more efficient in the aspect of pipelining under computer architecture. And then finally, the data path cycle has a huge impact on the CPU in the sense of the determination of execution speed and then affecting its throughput. So it affects the execution speed whereby it affects the execution speed whereby quick and direct executions are made. So as a result, so the data cycle can make the CPU have a can have an impact on the CPU, but the CPU determines how quick and direct execution is done. That is done, or that occurs is when the data path cycle is deeper, when the data path cycle is deeper and then shorter. So when it's deeper and then when it's shorter, execution is being carried out faster. And then on the aspect where it affects throughput, it's whereby the number, or when we say throughput, it refers to the number of execution which can be carried out per which can be carried out per unit time. Carried out per unit time can be done per unit time. So we are saying that the data path, or through the data path, has made it, or the data path has made the CPU, or has affected the CPU in a way that the CPU is able to determine is able to determine how quick and direct an execution can occur, and then can also affect its throughput, which I explained earlier. So moving on to the second question, which it talks about how the CPU fetches, decode, and executes instructions. So I'll pick it one by one. I'll start with the fetch. So first of all, the fetch concept is whereby the CPU retrieves information or instruction from the memory. So how does this occur? Okay, so firstly, from the aspect of the so firstly from the aspect of the firstly from the aspect of the ALU, whereby the CPU is able to reach for the register, or the data register, whereby data is being kept, and then through that data is being retrieved, or data passes through the data path. So basically the data, so as using the data path, so basically with the registers, it has a space of 1 to 32 bits randomly, or 1 to 32 bits by default. Yes, by default. So it is through the data path that the data flow occurs. So that is how the CPU is able to fetch, or is able to undertake the fetch command, or yes, is able to undertake the fetch command by retrieving data from what the memory, which is the register, and then passes through the data path, through passes through the data path, whereby that process is called the flow of data, or data flow. Now we move on to the next one, which is the CPU's ability to decode. So when we talk of decoding, it simply means breaking down. So this is whereby after retrieval from the memory, the CPU is able to break down the instruction it has received, or it has been able to retrieve from the memory, and then act on it, or determine what it's going to be used for. Yes. So how is this done? This is done after retrieval, whereby the CPU retrieves data from the data register using the through the through the memory data register, and then decodes or breaks down the data in the processor, which is under the control unit. So after after that is done after it is done retrieving, the CPU then breaks it down into simpler ways of which it can be produced as output, at which it can be produced as output. And then finally the execute. So the execution is then carried out, or the CPU is able to execute instructions when retrieval of data and the decoding of data has been done, and then since they have been determined, or since that data have been have or since that data have had its purpose being determined in the processes of fetching and decoding, and the execution, the CPU only carries it out. That is, it displays it as output to the user, or it displays it, or through the system displays it as output to the user, or whoever is using that system. So for example, you take an ATM machine, you insert you insert your card, you you ins you insert your card. Then after you key in your pin and then your options, and then so based on whatever you have keyed in, the ATM is able to know that this is what you want, and per the instructions you have given it, it is going to act on that. So for example, if it is 1000 cedis you are withdrawing, the ATM knows that it is due to the due as a result of you keying in that you are withdrawing 1000 Ghana cedis. The ATM is aware of that, therefore gives you exactly 1000 cedis. That's what the CPU does. So after decoding and fetching, the CPU executes or displays whatever it has been asked to retrieve from the data register. This is how simply the execution concept is. So in totality, we can we can we can come we can come to the conclusion that each step must occur, or each process must occur before the other. So the fetch must happen before decode, then decode comes before execute. So without fetching and decoding, there's no execution. Without fetching, there's no decoding. So once fetching has occurred, the code must follow, and it must end with execution. That is how the CPU is able to decode and execute instructions by just retrieving data from the register, or from the memory data register, register which is in the RAM. And all this is monitored by the control bus, which monitors the flow, which regulates and monitors the flow of data from the system's storage using timing. Once again, in conclusion, one must happen before the other. So fetch occurs before decode. Decode occurs before execute. Without fetch and decode, execution cannot occur. Without fetch, decoding cannot occur. Thank you for watching this video, and I hope you do understand. Thank you.